Hello, everybody. My name is Dirk Grupe. I'm one of the astrophysicists at the Space Science Center at Moritz State University. And what I'm usually doing is I'm studying supermassive black holes. I'm studying them in particular in X-rays. So I'm talking about are quasars, active galactic nuclei. And in order to do this, well, in order to observe X-rays, you need to go into space. You need satellites. And that's what we are actually doing in Moorhead. We have a program that is called Space System Engineering. And in space system engineering, what we teach our students is how to design a satellite, how to build a satellite, how to test the satellite, and then also when you are in space, how to communicate with the satellite. Now, typically when you talk about satellites, you probably think about, well, these are big things. These are something like school bus size of a minivan, several tons maybe. And they cost a lot of money, right? They cost something like hundreds of thousands of millions of dollars. And billions of dollars even, when you look at some of the satellites, they cost, a billion, $2 billion. But those are not the satellites that we are building. What we are building are what we call cubesats. And that is a cubesat here. This is a cubesat that was launched in 2012. Our students built this thing and designed it, built it, and then once it was in space, it was also controlled by our 21-meter antenna. And you will say, well, this doesn't look really like a satellite, right? I mean, looks like more like a toy. And in a matter of fact, when people invented this kind of satellite, what we call CubeSat, 25 years ago by Bob Twiggs, people were laughing at him. They thought, well, this is just a little toy, right? Well, guess what? Well, this is a fully functional satellite that I'm holding in my hand here because the 5 components that you see on every satellite is on this little one as well. And what do you need? You can compare pretty much your little satellite to your smartphone. And that brings me also back, why are we doing this, right? When you have your smartphone, imagine this, with your smartphone, even this is a relatively cheap one, you have more computer power than the Apollo missions had or any kind of space mission in even the 1980s. I mean, you still had to fill, rooms with computers and computers and computers, and those things were big, those things were very expensive, and only things like, government agencies like NASA could afford them. But now everybody has something like that that is much faster, that is much more powerful than what these guys had, 40, 50 years ago. Now, the same thing with the satellites. So Bob Twiggs' idea was, well, why don't we, with the miniaturization that we have seen in the computer industry, why don't we make the thing smaller? And when it's smaller, well, it's like your smartphone. I mean, this thing cost me what, 60, $70. And when you go back into the 1980s, I would have probably for something similar like that spent billions of dollars for this. And the same thing with the satellite. So this is CXPN, again, a satellite that our students built. And all the 5 components that you see on any big satellite is on this small one as well. So you always need power, right? So you need solar cells that powers the satellite. You need a battery to buffer the power. That's what you do with your smartphone, right? Your smartphone has a battery, and without the battery, you would be toast, right? More importantly, on your smartphone, that's also what we have here on the CubeSat. That's the radio right there, and antennas here on top. And that's the same thing in your smartphone because without the radio, the thing would be pretty useless. Also, you need a computer, and this thing has a computer as well. So the computer makes sure that all the components on our satellite talk with each other. The same thing on your smartphone. Your smartphone without your Android or with your iOS wouldn't work. Okay, it would be a brick basically. But with that software and with a computer, the components can talk with each other. And then, of course, we want to know with the satellite where we are in space, and we want to direct the satellite in space as well. So we have an attitude control and determination system. Very, very similar to your GPS on your smartphone, because on your smartphone you can also turn on GPS and you know where you are. And we have a magnetometer for this one, so we know in space where we are. And your smartphone probably has a magnetometer too, which tells you where on Earth you are, so you can use a compass for it. You can use also these sky map things, so you can look what constellations you are seeing. And it's the same thing with this one. So our satellite has a magnetometer, and with a magnetometer, it can figure out where it is in space. But your smartphone doesn't have this. We have magnetotorquers here, and they allow us to move the satellite around in space. So it's basically like a little electric motor. So once we send electricity through that wire, well, then every moved charge that produces a magnetic field. So that's why we get a magnetic field in this a satellite that works against the Earth's magnetic field, and we can rotate the satellite in all three axes. And then last but not least, here's the part why we are flying this thing. I mentioned this earlier. I'm studying active galactic nuclei, in particular in X-rays, so I'm using X-ray detectors. And that's what we have on board on this one. This is an X-ray detector that we call a CZT array, and that is very similar to the one that your dentist is using when your teeth gets X-rayed. And we built this in this satellite, again, was flown in 2012. And we have flown from Void, we have flown 7 missions so far. And we are building a big one right now that is Lunar IceCube. And I will talk about Lunar IceCube in another video. But I just wanted to give you a little bit of introduction in this little segment about what CubeSats are and what the components on a satellite are in general. Thank you very much.